right. Okay, so today we're going to be talking about Git and GitHub in this session. This is the intro room once again. So if you're looking for the advanced room, that's Alder 103. And feel free to decide partway through this that we're going too slow and you want to move over to the advanced. The goal today is to get introduced to Git and GitHub, to just kind of get a sense for what these tools are and get them all configured. We're going to work inside of the Jupyter Hub environment, and one consequence of that is that all of the configuration we do is going to be just inside the Jupyter Hub environment. So when you later go and configure this on your own computer, you'll need to do some of the configuration stuff again. Now, if you want to try to follow along in a terminal instead of in the Jupyter Hub notebook, that's totally fine. I will try to help you as much as I can. But it's possible you'll run into errors or something that I didn't anticipate is all. But feel free to try that. Also, I will try to monitor the Slack, but it's very hard while I'm lecturing to also monitor the Slack. So please interrupt me, shout out questions, especially for those of you on Zoom, just interrupt. We can hear you. Also, I put in the Slack website to this website that you're seeing right now. I guess Zoom people, you're probably not seeing that. Let me share my screen. Here we go. Okay. This website is actually part of the software carpentry set of lessons. I believe Satra mentioned software carpentry yesterday. Software carpentry is a great organization that has a bunch of lessons for data science related stuff, including Git and Python and the Bash shell, and even Docker. Will, in fact, the Docker lesson will also follow one of these lessons. We're not going to follow this lesson exactly, and I'm not going to sit here with this open. I'm just showing you where it is so you can come back to it later. This is intended as something you can return to and review on your own. But basically, this site has the whole lesson plan down here. We probably won't get through anywhere near all of this today, but we'll get as far as we can. However, to actually get started with Git, we're going to actually do everything in the Jupyter Hub, like I mentioned. So go ahead and go to the Jupyter Hub. Again, that's neurohackademy.2i2c.cloud. And when you get there, you should see something like this with the launcher. You've probably seen this before at this point. And we're actually going to do all of the work inside of a terminal. So in the earlier session, we used Python 3 notebook. But if you go down to here to this other section down here, you'll see this button for a terminal. And when we create one of those, we just get a terminal. This is basically a bash shell that runs inside of the Jupyter Hub. So I'm going to, in order to make this a little easier to see, I'm going to click this folder icon in the upper left, and that'll make this sidebar disappear. Okay, and here we have a terminal. Is that big enough for everyone to read it? Okay, yeah, okay, great. Okay, so Git itself is a tool for collaboration and for keeping track of things. It's primarily made to work with text documents like code. You can, in theory, use it with any kind of file. You can use it to track files and share files that are, for example, executables, or that are like a spreadsheet, like an Excel file or something like that. However, Git is intended to work with text. Oh dear. Did I lose you, Zoom?
We can still hear you.
You can still hear us. You just can't see anything?
I can see you moving your screen.
Okay, for some reason it crackled and disappeared on our end, and now it's back. So I hope that doesn't happen again. All right. Sorry, where was I? Yeah, Git is designed primarily to work with text files, and we'll see examples of that as we go. So really, Git was designed originally for code, source code files. And the idea is that very often, especially in scientific work, I'll be working on some analysis and I'll be writing some code. And I'm working on it with a collaborator of mine, and I need to send that collaborator the source code I've written, and they need to run it. And then they're going to edit it and they're going to send it back, and I'm going to run it with the changes. And that maybe kind of works for us, just sending emails back and forth with these files. It's not a very convenient way to share code. But as soon as you add someone else, and often we're working in much bigger teams these days, as soon as you add more than 2 people, it becomes very quickly becomes very difficult to keep track of the code, because I might make some change in the code that's very small, and you might make some change in the code that's also small, but that's to the same part of the code. And all of a sudden, we've got two different versions of the code, and we need to come up with some way of deciding whose version is right, or merging those two things together. And that for small examples, this is no big deal. But as soon as your code base starts to get very complicated, this becomes a real big problem. And Git is a tool that manages almost all of these problems for us. So we're gonna walk through this lesson basically, and we're gonna if you come back to this lesson later, it's not exactly the same. We're gonna start out a little differently. We're gonna start by going to GitHub. So just navigate to GitHub, github.com. You should have GitHub logins already. I think you had to have them to sign up. So I'm assuming that you can all just log in. Once you've logged in, let me make this a little bigger. Once you've logged in, you should see a window something like this. This is my login page, so it's got my repositories and stuff. But you should have a version for yourself. And the first thing we're going to do is we're going to make a repository. And what a repository is just a sort of bucket in the cloud that we can put files in and source code in, and we can share with people, and we can edit, and Git will track all of our changes and keep track of our history, and will allow other people to work with us. So to get started, you can go up to this plus icon in the upper left, or upper right, sorry, and go to New Repository. That'll take you to this page here, Create a New Repository. We're not going to pick a template. A template is if you're trying to make some kind of repository that's just like someone else's. We're going to skip that. Here it has owner, it will have your username here. And then for the repository name, we're just going to call it planets. And the reason for that will become apparent as we go through the lesson. Now, if you've got an X here, that means you've probably gone through this tutorial before. And if you did, just name it something else and just remember what that was. Okay, we're not going to put a description for now. We're going to go ahead and leave this as a public repository so anyone can see it. And the rest of these we're just going to leave for now. And then I'm going to push this Create Repository button. Okay, so now we have this page here that's basically a bit of information about our new repository. So here you can see the repository name in the upper left. The repository name is my username / the repository name. So Noah Benson / planets for in my case. And down here, there's some instructions on how to do a quick setup. So this is basically telling you how to get the repository off of GitHub and onto your computer. So we're going to follow these instructions, and you can go ahead and copy this address here. Make sure it's clicked on SSH, but you can go ahead and copy that address. And then we're going to go back to our terminal. Okay, so back at the terminal, what we want to do is we want to pull whatever the GitHub repository we just made. We want to pull it down onto our local computer, in this case, onto our local Jupyter Hub instance. So to do that, we're going to use the Git command. So Git clone, and then you can paste. I'm going to type it out. It's git at github.com, and then a colon, and then your username. So for me, that's Noah Benson, and then slash, and then planets. Okay, so here it's giving me a little warning that's saying I can't establish the authenticity of github.com. This is based on a sort of theoretical kind of hacking attack that people can do. In theory, if someone had clipped the Ethernet cord that ran out of my computer and stuck the other end into their computer, they could intercept my request to connect to github.com and send me a fake credential back. And that's why this is asking me to say, yes, I'm okay with this credential. Basically, this is not a real concern for us for most of the time. So I'm just going to say yes here, and you should be fine saying yes as well. Now it's telling us that we don't have correct access rights. So the reason for this is because we just made a repository ourselves, and we just told GitHub to clone it over SSH. And cloning over SSH is kind of tricky. You actually have to do a little bit of setup. So we're going to do that now. Now in the lesson online, you don't do this first, but this stuff is really important, and I don't want us to get only partway through the lesson and not have this all done already. So we're going to do it now. Okay, so 1 second while I get my notes. So there's a program called SSH-Keygen that is built into to Linux and Mac and pretty much any POSIX-like system you have. And I just want to make sure I get this command line exactly right because it's a little tricky. Yeah, okay. So what the SSH Keygen command does is it generates what's called a credential, a set of credentials. So what it'll do is it'll generate two files, one of which is a private key and one of which is a public key. Most modern encryption is based on this idea of a private key and a public key. There's a bunch of fancy math involved, and the idea is that if I have a private key, I can take that private key and encrypt a message in such a way that anyone with the public key can decrypt it, but only someone with the private key could have made the message. So I can make the message with a private key and give it to you, and you can be certain that I made it. On the other hand, anyone who has the public key can take the public key and take any message, and they can encrypt it in such a way that only someone with the private key can decrypt it. So if I make a private key and a public key, and I publish the public key to the web so anyone can see it, anyone who has that key can then make a message that only I can decrypt. And similarly, I can make a message that anyone with a public key can be confident only I wrote. That's basically, we're going to generate some keys and give the public key to GitHub so that GitHub can always know that we're who we say we are, and so that it can send us stuff confidentially. Does that make sense? Anyone have any questions about that? Okay, it's not real important that you understand the details of how this encryption works. It's just important that we get it set up so that we can use it. So we're going to say SSH Keygen. We're going to say -t. And then there's this particular kind of key that we're going to make, and it's ED 25519. This is a particular ED 25519 happens to be an algorithm for generating public keys and private keys. There's others, but we're going to use this one. Okay, and then we're going to say -C. And you're going to put whatever email address you used to sign up for GitHub with. So for me, that was n@nben.net. So that's what I'm going to put. But you should use whatever email address you used for GitHub. Okay. So it's asking me enter the file in which to save the key. And notice that it's in this .ssh directory. That's the normal place you would put these keys. So we can just push enter. That's fine. Now it's asking for a passphrase. Now, this is a little unintuitive. Typically, you want to put a passphrase on things like keys and stuff. But in this case, the purpose of this key is to be stored in a place on your computer where only you can read it. And so it's totally fine to not have a password on this key. I typically don't put passwords on my SSH keys that are on non-shared computers. So as long as it's on your laptop, it's fine. This, of course, is in the Jupyter cloud. So you're probably not going to use it outside of NeuroHackademy, and we're not going to go steal it, so you're welcome to not put a password on it. I'm not going to. I'm just going to push enter twice. If you do put a password on here, it will ask you for that password every time you try to do anything with GitHub or with Git. So just be aware of that. Okay. Yeah.
Is there a caveat to putting a passcode versus not?
Yeah, the only real consequence is that if you put a password on it, every time you or anyone tries to read that file, you have to enter the password. So when you type git clone, a minute ago I typed git clone and it said, we don't know who you are, basically. Come up with an SSH key. If I put a password on that file and I type git clone again, I'll have to enter that password before git clone will work. If I don't put a password, it'll just run. That's the main consequence for during this lesson. But my general advice is there's no reason to really put a password on these if you're storing them on your own private computer and there's no one else who uses it. If you're on a computer that you share where there's other people who can log in with your user ID, you should definitely put a password on this. Any other questions so far? Okay. All right, so I'm going to go into that .ssh directory just to look at what happened here. If I type ls, you can see there's this this file here, ID underscore ed25519. That's the private key. The public key is ID underscore ed25519.pub. And I'm just going to type cat id underscore ed25519.pub, because this is the public key. It's perfectly safe to share this key. It's perfectly safe for anyone to see it. So that's the public key. And what we're going to do is we're going to go ahead and copy that whole line, Command C, and we're going to go back to GitHub. Okay, so once we're back at GitHub, you can go up to your user icon in the upper right. For me, it's a little picture of my face, but for you, it might be some symbol, depending on whether you've uploaded a photo. You can push the down arrow here, and you can go to settings. And then on the left-hand bar here of the settings page, there's an item called SSH and GPG keys. We're going to click on that. And there's this entry for SSH keys. Now, I have a couple of SSH keys. You may not. You might. It depends how you've used GitHub. But regardless, what we're going to do is push the new SSH key button. And in this key area, I'm just going to paste that exact line I copied just a second ago. So again, just to reiterate how you get here, from the Jupyter Hub, you can cd into your .ssh directory. You can cat the file that ends with .pub, and then you just want to copy this whole line and bring that over to the SSH window over here. I'm then going to give this a title, so I'm just going to call this NeuroHackademy Jupyter Hub key. And once you've got that entered, you can push add SSH key.
I'm sorry, how did you get to that page on GitHub? I'm not seeing it.
Great. So you start by going to the, there should be some kind of icon in the upper right corner with a little down arrow.
Yeah.
And on here is an entry called settings.
Oh, settings. Okay, sorry, I missed that.
No problem. And then there's SSH and GPG keys on the left.
Got it. Okay.
Yeah. And then you push new SSH key. Does anyone else have any trouble getting this to work? Yeah. After you say that again, after you change. Oh, yeah. Gotcha. So I cd'd into .ssh, and then I did cat. Cat is a command that will just, it's for concatenate. It takes whatever file you give it, and it just prints the results out to the screen. So basically, I said print out the file that ends with .pub, so id underscore 25519.pub. And then I just copied this whole line and put that in the SSH box. Yeah. No. Okay, that's a great question. The question for those on Zoom was, do you have to do this every time you create a new repository? No. This the whole purpose of these steps is to tell GitHub that your Jupyter Hub instance or whatever computer has this this key, what that does is tell GitHub that this computer is you and is allowed to connect to GitHub as you. So the idea is when we typed git clone at the beginning, we went the git command line went up to GitHub and said, hey, I want to clone this repository. And GitHub said, I don't know who you are, because we didn't have any way to log in on the command line. So now that we've made this key and we've told GitHub about the key, GitHub will send us a message saying, can you prove who you are? And what the Git command line will do is it'll take that private key and encrypt a message saying, this is who I am. And then GitHub will know it's us making the request. So the whole purpose of this is to set up this one computer, this Jupyter Hub instance in this case. So you do need to do this for every computer you run Git on, but you don't need to do this for every repository or anything like that. But that's a great question. Yeah. Did you, by any chance, type git clone https://? Yeah, that's why you didn't get it. Okay, that's fine. So I can just talk a little bit about that. There's multiple ways to connect to Git, and we're going to use SSH in this lesson because that's sort of the more contemporary way to do it. It used to be that instead of, so I'm going to cd ... here, go back to my home directory. It used to be that instead of git clone git at github.com and then the repository, we would instead type git clone https://github. And then you would put the repository. If you do it this way, it connects via HTTPS instead of SSH, and so it doesn't care who you are. The problem is that later when we try to make changes to the repository, it won't let you make changes when you've done it this way. So if you didn't get an error and you went ahead and cloned the repository, I'm going to recommend that you type rm-rf/planets like that, and delete that planets directory that you just cloned, and then reclone it with the git add GitHub command. Okay, so, and I will reissue that command in just a second if you want to see it. Any other questions so far? I just want to make sure we're all on the same page here, because this is the kind of complicated setup part, and then after this it'll be more like commands and stuff. Okay, so now that we've set up this SSH key, I'm going to go ahead and say git. There's just a couple more things we need to do, and these are just basic configuration items for Git. So first of all, we want to tell Git who we are. So we can say git config. This is the command for configuring Git. And just want to make sure I get this command right. We want to say -- global. So the -- global tells Git that we're configuring it for not just the current directory, we're configuring it for every use of Git. So that's for identifying ourselves, global is appropriate. So we're going to say user.name, and then in double quotes, just put your name. This is not your username on GitHub, this is just your name. So I'm going to say Noah Benson. And then one more, we're going to say git config -- global user.email. And here you want to put, also in double quotes, put the email address you use to sign up for GitHub. So for me, this is anna@nben.net, but for you, it's whatever email address you use to sign up. We can also, just to tell you a little about the config command, we can say git config -- list, and that will show us all of our configuration settings. Now, these aren't necessarily very meaningful. These are specific to the Jupyter Hub stuff, but you can see the two items we just set here, the username and email.
Quick question. So anyone that wants access to the same GitHub repository would just do it with their own account. So they would have to set up. Okay.
Yeah. So as long as GitHub knows who we are, it'll let us clone. You don't actually have to be, you don't have to own a repository, especially, say that again. If a repository is public, you do not have to own it to clone it. You can clone any repository as long as GitHub lets you log in. So you can actually clone my planets repository if you want. You just won't be able to edit because you're not me. So okay, so let's go ahead and do the git clone now. So we do git clone. Again, we do git at github.com, and then we do colon, and then your GitHub username. Now, it'll work if you put my GitHub username here. It's just that you won't be able to make modifications to the repository later. But put your GitHub username, and then a /, and then planets. Okay, so this time it worked. It does say we appear to have cloned an empty repository, but that's fine. We just made it, so it is empty. Now, if we type ls here, we'll see that there's now a file called planets. That's actually a directory. So I'm going to go cd space planets. And it's just an empty directory right now. So there's nothing we can really see here. But we have now successfully cloned this repository. And in fact, if we type git status, it will tell us that this is a repository. We're on what's called branch main. We're on the main branch of this repository. We haven't made any commits yet. We'll talk about what a commit is in a minute. But essentially, this is all work. So did that work for everyone? Did anyone have trouble or have any errors? Awesome. That's great. Okay. So at this point, we've already created our repository, but I just want to introduce this particular lesson. Is a little silly. It's about this concept of the Wolfman, Dracula, and Mummy are all exploring the solar system in search of interesting planets, something like that. And so all of the examples we're going to be doing involve Wolfman, Dracula, and Mummy. I didn't write this lesson. It's just the lesson that Software Carpentry came up with. But it's a good lesson. It's just got a kind of funny setup. That's just context, so you understand why I start typing stuff about Wolfman and Dracula and stuff, not anything very important about the lesson. Okay.
Sorry, just one question to clarify. So you created a repository called planets, right? It's not anything else other than that. Okay, just wanted
That's correct. Yeah. Yep. Yeah. Okay, by any chance, did you put a slash instead of a colon between github.com? Yeah, so that's the error I make most often, is that you'll say git clone git at github.com and then, whoops, and then you put a slash here. If you put a slash there, it won't work. You have to put a colon and then your username and then the repository. If that works, then you're probably fine. Okay. Okay. Okay, so we're in this planets repository and it appears to be empty. When we say ls, there's nothing. But if we type ls space -a, which is list everything, including hidden files, we'll see that there's a file here called .git. Now, files in Unix and Linux that start with the dot are just by automatically they're hidden. They're there in the directory, but when you type ls, it doesn't show them to you. So this is just a hidden file. And inside of this file, it's actually a directory. And inside of this directory is a bunch of information that Git keeps track of. In general, you don't want to peek inside of this directory. It's there. It keeps all of the information in it. But editing the files inside of here is generally a bad idea. That's what the Git command line is for. I just wanted to show you that that was there. Okay. All right. So we've made a repository. Let's go ahead and add a file to it. Now, we're going to work with text files. These files are all going to be about Wolfman and the Mummy and stuff. Typically, these would be some kind of source code files, or sometimes a set of LaTeX files if you're doing a paper in LaTeX together. But for me, most often these are Python files, but we're just going to be using text files today. So let's go ahead and we're going to run the program Nano. In case you're not familiar with Nano, Nano is a very simple text editor for the terminal. It's already installed on the hub, and we're just going to say nano mars.txt. So we're opening up a file called mars.txt. So here's what Nano looks like. Basically, it's just a simple editor. You can use the arrow keys to navigate. You can type. All the commands are down at the bottom. These little carets, like this caret K, means control. So that means control plus K is how you cut text. All right. So in this mars.txt, this is presumably Dracula, I think, talking, and is just going to write some notes about Mars. And the notes are cold and dry, but everything is my favorite color. Okay. Now to save this, I'm going to push Control and O for write out down here. So Control O. It's going to ask me to confirm the file name, and mars.txt is fine. So I'm just going to push Enter. And then the exit is Control and X. So I'm going to Control X. And now if I ls, there's this file mars.txt here. And we can cat it just to make sure that it came out right. And that looks fine. Okay, so have we now added a file to Git? Well, if we type git status, what it's going to say is still nothing committed. We haven't committed anything yet. And there's this untracked file here called mars.txt. So what this is really telling us is that our GitHub repository doesn't know what this file is. We've put a file here, but we haven't told it what it is. So it just thinks this is maybe some notes we wrote to ourselves, not part of the repository. So let's go ahead, and what we want to do is commit this file. So what I'm going to type is, first of all, git add. You notice here it says nothing added to commit, but untracked files present. That's this file here. And it says use git add to track. So I'm going to say git add mars.txt. So this tells Git about this file, and it tells Git that this file is going to be part of our repository. However, the add command, yeah, go ahead. Oh, so when you're in Nano, you push Control-O to write it out, and then it'll ask you to confirm the file name, and you just push Enter, and then you push Control-X to get out of Nano. Yeah. Okay. So the git add command basically tells the GitHub repository that we have started making some edits, and this file here is part of those. We still haven't actually done anything. We still haven't made any commits yet, but we're going to do that now. So once we've added something, we can git commit, and then we can put -m, which is for message. Every time you commit something into the repository, you can put a commit message, and I encourage you to always put a commit message that tells you whatever you've changed or whatever this commit is about. So in this case, we're going to say started notes on Mars as a base. And then we'll push enter. And here it's going to print our commit message back to us. And it says one file changed. It's got a little bit of information here. Okay, now if we type git status, it no longer has that message about there being a file that it doesn't know anything about. Do you have a question? Mm-hmm. Yeah, Control and O. Yeah, just push enter as long as it's mars.txt. That's just confirm the file name. Yeah. Yep. Yeah, so this is a little, this is a source of confusion quite often in Git. So the idea is that oftentimes when you're making a bunch of changes or a bunch of edits, you're editing multiple files at once, and you want to commit them all as one big commit. You don't want to commit each file separately as separate commits. So this happens all the time in source code, where you've got like a library where some function relies on like 4 different files, and you go and you fix something in all 4 of those files. And then what you want to do is you want to commit them all together. And so you add all 4 of them, and then you commit once. So that's kind of the idea. What git add actually does is it puts whatever file you add into what's called the staging area, the Git staging area. And the staging area is basically the set of files you're like currently working on and that are ready to commit. So git add is sort of an initial step in git commit. You can also, and this is how I work most of the time, you can just type git commit -m, and then you can put files. So we could just say mars.txt like that. You don't actually have to add. It's just that people typically add because it's a way to kind of keep track of what you're working on as you're going. Does that make sense or answer the question? Yeah, exactly. So just for people on Zoom who probably can't hear very well, the question was basically, so if you have like several files and you've modified like 4 of them, would you go ahead and add the ones you just modified? And that's typically exactly how you do it. And usually how I would do it would be I would edit the first file, and as soon as I was done, I would git add it, and then I would go on and edit the second file, and then whenever I was done with whatever I was currently working on, I would commit it all. And just to be clear, I haven't explained this very well yet, but once something's committed to the repository, it's in the repository pretty much permanently. It is possible to delete things from repositories, but it's a lot of work, and they're not made to work that way. Instead, what Git is supposed to do is it's supposed to keep track of everything you've ever done. So you can always rewind back to any point in all of your edit history. And it does that in units of commits. So you can rewind to any particular commit you make. but not to any particular edit you make, if that makes sense. So like if I make 10 edits and commit them all at once, I can go back to that commit before it, or I can go back to right after it, but I can't go back to in the middle of it. I can't go back to some of those edits, but not others. So that's part of the reason you sometimes want to commit things together or not commit things together. Okay, any other questions? This is a good, yeah, go ahead. Yeah, that's a great question. So for Zoomers, that the question is, practically, would you usually want to commit 10 things at once, or would you want to make 10 commits in sequence? That depends entirely on what you're doing. So the way I think about it is, if I'm making a bunch of discrete commits that are not necessarily related to each other, or that maybe are related to each other but don't depend on each other, I would probably do them as many commits, because that makes it easier to go back to different steps in the process of making the change. However, if what I'm doing is making changes to 3 files, where if you had only one of the sets of changes, if only one of the files was changed, everything would be broken. But as long as you have all 3 files changed, it all works. That's when you want to commit those 3 files as one commit, because that way people won't accidentally roll back commits until the state is broken. So just to explain that a little bit more clearly one more time, maybe with a simpler example, if you have 2 files and the 2 files depend on each other, where like the code will only run if you make a change to each, or if you don't make a change to each, then you wouldn't want to commit just one of the files, because if you unrolled, if you rolled back to a commit where only one of the files was changed, the code wouldn't work anymore, because you have to have either both changes or neither change. Okay, yeah. Yeah. Yeah, so that's a good question. So the question for Zoomers was, so far everything is on Jupyter. Has anything gone to GitHub yet? So we actually did make the repository on GitHub. So the repository, an empty repository, is on GitHub. But this commit was actually just to our local computer. There's a Git repository that we cloned from GitHub on our local computer. And when we commit to it, we commit to it, not to GitHub. So a little bit later, we'll talk about pushing, where we will push our commits to GitHub, but we're not there yet. Yeah, but that's a great question. Okay, other questions? All right. Okay, so we already did that commit, so we're not going to do that.
I have a quick question, sorry.
Oh, yeah.
If you wanted to commit, or if you're committing more than one file, is it just separated by a space? Like we committed Mars.txt. If you wanted to commit like Jupyter.txt and Earth.txt, would it just be separated by spaces?
Exactly. So you can, there's a few ways to do that. You can git add Mars, and then on the next command, you can git add Jupyter, or you can git add Mars space Jupyter, or you can just git commit -m message and then space Mars space Jupyter. So all of those will work just fine. Yeah, whichever you're most comfortable with. Okay, so now let's suppose we come back a few days later and we want to see what we did last time we were editing this repository. There's a command called Git Log, which will tell us what we've committed. So here, this is saying, here's our first commit to the repository. It says who made the commit. That was me in this case for mine. When it was committed, and our commit message. Now we've only got one commit in this repository, so there's not much of a log, but we'll come back to this as we go. Okay, so let's kind of keep going with this. Let's go ahead and open up that Mars.txt again with nano. And I'm going to go down to the next line and add the 2 moons may be a problem for Wolfman. Man. Okay, and then I'm going to push Control O and save it, and then Control X to exit out. All right. Now, if we type git status at this point, we have a similar message that we had earlier. It's not that there's an untracked file or something it doesn't understand, something that's not part of the repository, but it's that we've modified a file that's part of the repository. And that's basically what it's telling us here. So with this file, it's just 2 lines, so it's very easy for us to keep track of what's changed. But a lot of times when you're editing code, especially if you're editing across many days, it can be very hard to remember what you've done. And there's a command for that that's great, that's called Git Diff. And what the purpose of this command is to show you the difference between whatever changes you've made and the repository before you made the changes. So if we type Git Diff, we get back this kind of complicated message. The beginning of this is all just information about what we're comparing. But down here at the bottom, there's the first line of the file, which is the same in the repository and in our current version. And then there's the second line, which starts with a plus. And what that plus tells us is that this is a line that's new in our current version, but is not in the committed version. So just as a reminder, if we cat mars.txt right now, we see both lines. But the version we've committed only has that first line, and that's why it's saying, here's the difference. You've added this line. Okay, any questions about that? Yeah, so this is basically, this is telling you, okay, so you could imagine instead of having it tell us this way, that, hey, here's the new line, it could have instead said, hey, the original file is missing this line, and it could have been a minus. So if, when you do git diff, it always does it the intuitive way, where it's showing you what's changed since the last commit. But the diff command in general, you could do that either way. And it's capable of telling you, yeah, you've deleted this line since the last edit. So up here, this is, honestly, these two lines don't have a whole lot of meaning because we're comparing a version of mars.txt that's here versus a version of mars.txt that exists in the repository, but is kind of not a real file. So these two lines are sort of an artifact of the diff command, is how I would think of it. But if normally when you run diff, those two tell you what two files you're comparing. Yeah. And then some of this is telling us where in the file, it's like the line and column number where the change occurs. Yeah. That's a great question though. Okay. Any other questions? All right. All right, so let's go ahead and commit this. This time I'm going to just, without git adding, I'm just going to commit. Add concerns about effects of Mars's on Wolfman. And I'm going to say mars.txt. Okay. I meant to, well, that's okay. All right. So we already talked about the staging area, so I'm going to skip over that. Okay, so let's make one more change here. We're going to go ahead and say, add one more line, but the mummy will appreciate the lack of humidity. And once again, I'm going to Control O to save and Control X to exit. Okay. Now let's look at a git diff. Once again, now since we committed that last change, you can see that the new line is the only difference now. So it's always comparing to our last commit when we do git diff. Additionally, we can git diff and we can give it a file. So if you run git diff without any arguments like we've been doing, it'll show you all the differences in your repository. And if you have lots of files, that can be lots of things. But you can also say git diff mars.txt, and it'll just show you the diff for that one file. In our case, that's not really important yet, but it'll be important later. Okay. Also, I want to mention that you can add mars.txt here. So let's get add mars.txt since we have this new change. And we can then say git diff -- staged. So remember, I mentioned that when you add something, you're conceptually adding it to the staging area. It's sort of the stuff that you're getting ready to commit. Git diff -- staged will tell you whatever's different between what you've staged and what's committed. So it's just a way to get a diff on everything you've added. Okay, let's go ahead and commit that. Once again, I'm going to add a message. discuss concerns about Mars's climate for Mummy. Okay, and then git status. Everything looks fine. Now we've made a few commits. We've made like 3 commits now. So let's look at the log again. Git log. And now we see that there's a series of commits here, and each one has every single one has the author, the date, and then the commit message. And this is a really useful command for seeing what's happened recently. However, it can get very noisy. It can produce a lot of text. So there's a few ways you can simplify it. First of all, if you just want to see like the most recent commit or the most recent 2 commits, you can say git log and then dash and a number. So like git log -2 will show us just the last 2 commits. Here's the command. So that just showed us 2 commits here. Additionally, we can make this a little more concise by saying git log --1 line. And that --1 line tells it to just make the messages about each commit a little shorter. So here we have every commit just gets a single line. So this is a way to kind of see our history very concisely. Oh yeah. Right. So so the question is, with respect to git add and git commit, what's the difference and why do you not see changes when you git add and type git diff? You don't see the changes with what you just added. Yeah. So when you git add, you put something in the staging area, which is sort of like halfway between committed and not committed. So when we make edits and we say git diff, Git tells us what's different between the current committed state of the repository and whatever you've changed but you haven't added yet. Once you add something, it goes into the staging area, and then the git diff command will ignore it unless you say git diff -- staged. And that's a way you can see specifically the difference between the staged stuff and the commit stuff. However, when you've added something, it's still not permanently stored in the repository. It's still just a change, and so it's pretty easy to undo that add. That said, that's not actually something I do very often. So for the most part, git add is just a way to kind of prepare to commit a bunch of stuff together. And then once you commit, it takes whatever you've added and it puts it in the repository permanently. And from then on, when you do something like git diff, it will compare that state of the repository to whatever is currently in the directory. Yeah. Correct. Yeah, you don't need to do git add before you do git commit, but it is often useful for kind of collecting things up and committing them all at once. Yeah. Yeah. Okay. Any other questions? Yeah. That's a great question, and actually, let me just talk about directories now. Okay, so the question for Zoomers was essentially how does Git deal with subdirectories? So yeah, let's go ahead and make a subdirectory. So I'm going to make dir moons. Okay, and then I'm going to cd space moons into the moons subdirectory. So one hypothesis is that moons is part of the planets directory. Another hypothesis is that this is its own Git repository, or maybe it's none of those. And the easiest way to find out is just to type git status. And you'll notice when we type git status that it seems to know that we're in a GitHub repository. So that's something. Now, just for reference, I'm going to c space dot dot and c space dot dot. So now I'm in my home directory. I'm not in a GitHub repository at all. And if I type git status, it's going to say fatal. This is not a Git repository. So let's go back into planets / moons. So clearly this is part of a Git repository. So, but how do we know if this is the moons repository or the planets repository? Well, one way would be to say git log, one line. And you notice here that it's got all of our history for the planets repository. So actually this subdirectory is part of the planets repository, and that is how Git deals with subdirectories. So Git actually handles subdirectories a little bit unintuitively. If you're in a subdirectory of a repository, then you are in the repository. All subdirectories belong to the repository. However, Git doesn't explicitly track directories. It just tracks files, and files are allowed to be in subdirectories. So you cannot commit a directory. The only thing you can do is you can commit everything inside the directory. You can't delete a directory from a repository because the only thing you can do is delete all the files from inside the directory, and then the directory is no longer there. So it's just a little bit unintuitive. Basically, directories, Git always figures out what directories you have based on the files you have, and you can pretty much just ignore them. You don't have to like add them or commit them or anything like that. Any questions about that? Okay. So just to be explicit, we can also geez, I don't know the names of any of Mars's moons. So I'm going to do io.text. We can add a file in the moons directory. I honestly don't know anything about. So that's going to be the message. I'm going to save that and exit out. And here we can go ahead and git commit -m. Added a simple message about io, io.text. And whoops. Let me go ahead and git add io.text and then git commit io.text. There we go. So you notice that it committed moon/io.text. And that's because the path to this from the planets repository, the path to that file is moon/io.text. But we didn't need to commit the moons directory or anything like that. And if we do git log, we'll now see that there's a commit message for this io file. So you can treat files and subdirectories just like regular Git files. They're part of the repository. Okay, any other questions so far? Okay, so let's talk a little bit more about history. And to start, let's go ahead and I'm going to open up the mars.txt file again. And I'm going to make a change, but I'm going to make a change that we don't want, that we're going to try to get rid of in a minute. So I'm just going to say an ill-considered change. Okay, I'm going to save out that line, Control O and Control X. Okay, so we can of course Git Diff and see that there's this new line here. All right, and now recall that when we say git log, there's all these different commits, and there's part of this log that we haven't talked about, which is this weird string that comes after the commit here. So this is actually a commit ID. It's a big, long kind of gobbledygook string, but it's a unique identifier for this particular commit. Same with this and same with this. And you notice also that there's this head arrow main here. The head of your repository is actually just the current state of the repository. So all the commits together, when you start with the repository and you pile all the commits on top of each other, you have the head. So we can actually type git diff head. That's saying I want to compare the head of the repository to, and we can say mars.txt. Okay, so that did the same thing as just git diff mars.txt. There's nothing special there, but there's a shortcut we can use, which is git diff head ~1. That means go back one commit from the head, mars.txt. Okay, we didn't, our last commit was that IO file, so head tilde 1 doesn't actually change anything. So let me say git diff head tilde 2 mars.txt. 2 commits ago, we added this line about the mummy. So before those 2 commits, the repository just had these 2 lines in it. So when we compare the repository 2 commits ago to our current repository, we see that there's been 2 lines added since that state of the repository 2 commits ago. Okay. Did that make sense to everyone? Any questions? Okay. So that's one way we can look at the history and compare the history. Additionally, we don't need to use that head. We could also take this, this string and use that as an identifier. So if we want to go back all the way to our very first commit, I'm just going to copy that string and say git diff, and then paste that string, and then mars.txt. And since our first commit, which is the first commit is where we added this first line, we've added 3 lines to that file. So you can use head tilde number to say back a certain number of commits. And you can use the commit ID if you want to say, I want to look at the difference between this particular commit. You can also say, hey, git show me what mars.txt was like 2 commits ago. So git show head tilde 2 for the commit. Or you could use a string like this here, and then the file you want to see, and it'll print out sort of a similar bit of history here and a diff at the end. Okay, any questions so far? All right, so let's go ahead and right now we've added that ill-considered change, but we haven't committed it. So I'm just going to go ahead and git commit. This time I'm going to use a slightly different form of git commit. I'm going to say git commit adding an ill-considered change, and I'm going to put -a. Oh yeah, question. The list of commits made to a specific file. That's a great question. I don't know offhand if there probably is a command for that, but I don't know it offhand. That's a great question though. Yeah, so for those on Zoom, the question was, is there a way to see a list of commits for a specific file? Yeah, I think there probably is, but I just don't know the command. Typically you use Git Log and just look for the file, or if you go to the GitHub website, there's ways to see it too that we'll look at later. Yeah. So sorry, when you're just like this command right here, like on the command right here, and you type git diff, and you don't see this ill-considered change, go ahead and cat mars.txt. It's possible you forgot to save your file before you exited. If you see this line in your mars.txt and it's not showing up in the diff, that's weird because that implies you committed it somehow. You see the line? Sorry? Okay, it's possible you might have git committed, or if you pushed enter on that line I had partially typed. But most likely, if you don't see anything in the diff, it means it got committed. You might check Git log to see if you have a commit for that line. Yeah. Any other questions?
So just to clarify on that, so Git diff will only show differences between git add and git commit, not if you've already committed, correct?
Not quite. So git diff by itself, what it shows you is the difference between whatever's committed and whatever hasn't been added. So if I go ahead and git add mars.txt, so at this point I haven't added or committed this change, so it's showing up in the git diff. But if I then git add mars.txt and type git diff, no change, no changes, because I've now staged that mars.txt file. Okay, so now ironically I didn't actually want to stage that text file, but that's okay. So that was this is kind of a mistake. So we rather than commit it, I want to get rid of it. So I'm going to go ahead and use a command called git checkout, And what I'm going to say is I'm going to check out from the current head mars.txt. And what git checkout does is it goes to the repository and it pulls whatever file you're asking for out of the repository. And you can ask it to check out a much older version of the file if you want by going back to like head ~3 or something, or you can check out the current version. Okay, and so now if I type git diff, now of course I added it so that wasn't showing up anyway, but let's cat mars.txt. And you'll see that that last line is now gone because we checked out the older version of this file. We could similarly look at our Git log and go back to our older commits and say git checkout, and we'll paste this commit ID and then say mars.txt, whoops. And now if we cat mars.txt, it's the very first version we committed with just one line. However, checking out a file doesn't actually change the repository. It just changes the current directory you're working in. So again, this directory, this planets directory, that's sort of a scratch space for us to work in. That .git directory that we looked at earlier, that we can see if we type ls-a, this Git directory is where the repository actually is. And when we check out files, we don't change the repository, we just change the workspace. So if we type git diff now, well, that's interesting. I didn't actually know that typing git diff in this situation wouldn't show us anything. But anyway, if we type git status, we'll see that mars.txt has been modified. And that's because the current state of the repository, mars.txt has 3 lines in it. We've committed 3 lines. And if we say git log, we're going to see all the same commits we made. So we haven't actually changed the repository by doing that checkout command. Now, we could commit this version of mars.txt, and that would change the repository. But as of now, we haven't actually changed it. And in fact, I don't really want to change it. I think our commits were fine. So I'm going to go ahead and git checkout again from head, from the current version of the repository, mars.txt. Okay. Any questions so far? This the checkout, you mean? Yeah. So okay. So for Zoomers, the question was just to kind of re-explain the checkout mechanics. So basically, the idea, usually the way that I use checkout is I'm editing a file and I realize halfway through that I've just completely screwed up and I need to go back. I need to blow away everything I've done so far and start over. In that situation, what I would do is I would say git checkout, whoops. And then I would say, from what point in the history of the repository do I want to check this out of? And if I say just head always means the current state of the committed repository. So if I say git checkout head mars.txt, what that says is, hey, git, blow away this mars.txt file and replace it with the current mars.txt file in the committed repository. On the other hand, if I said head ~1 here, that says go back 1 commit in the repository and check out the mars.txt from that state in the repository. So in a way, this is a way of rewinding the repository and saying, hey, what was the repository like a few commits ago? Yeah. Any other questions? Okay.
I have a quick question regarding the subdirectory. So like, for instance, we're in the planets directory, and I know you mentioned that repositories don't have subdirectories, but why can I not, like, for instance, nano the planets.txt if there's no subdirectories in GitHub, if that makes sense?
So it's not that GitHub doesn't have subdirectories, it's that it doesn't track subdirectories by themselves. So you can't add a directory by itself. You can only add a directory because you've added files that are in the directory. So we can edit mars.txt here or any other file.txt inside of this planets directory or inside of the moons directory, and we can add them to the GitHub repository, and that's all fine. But what we can't do is add an empty directory to the GitHub repository. Does that make sense?
Yes, thank you for clarifying.
Yeah, no problem. Okay, other questions? All right, so let's quickly talk about ignoring things, and then we'll go on to pushing. Okay. So a lot of times with a lot of programming languages, especially, when you run stuff, these programming languages will generate some extra files that are part of running the code, but that aren't actually part of the code. If you've done enough Python programming, you might notice that sometimes when you run a library, it'll create a file called __pycache__ somewhere in the directory. That's just something that Python uses to keep track of kind of internal data. It's not actually part of your code, it's just stuff that Python creates. This is a pretty common problem. Another thing that often I do is I'll write notes to myself in a repository directory, but I don't actually want to commit them to the repository. I just want them for myself. So let's suppose we wanted to do that. I'm going to open nano-notes.txt, and I'm just going to say I'm not too sure about that. Whoops, those notes on IO. And I'm going to push Control-O to save and Control-X to exit. Okay, so now if we type git status, we see that there's this notes.txt file, and it's saying you haven't added this to the repository yet. And that's honestly, I can just leave this and have notes.txt be here and have this message all the time. And that's not really a problem. But a handy thing is that you can tell GitHub to ignore that file. And to do that, we're going to open a file called .gitignore. Now notice this is a file that starts with dot, so it will be a hidden file in this directory. But we'll go ahead and open that. And I'm just going to put notes.txt. I just want it to ignore notes.txt. And I'm going to push Control-O to save it, Control-X to exit.
Is Nano the only editor that you can use, or can you use others?
Oh, no. Nano has nothing to do with Git. It's just a way of editing text. Git actually doesn't care how you edit your text. It just cares about the text. So I'm using Nano because it's installed on the hub and we can all use it. In real life, I mostly use Emacs. You should use whatever editor you're comfortable with. There's lots of good ones. There's no reason you have to use Nano. Yeah. Someone else had a question too. Oh, I had a typo. You're right. Noticed. Okay. Fix that. Oh man, I'm on a roll. Okay. All right. So I'm going to move .gitignore to .gitignore. There we go. Okay. Hopefully you all got it right when you did it, despite my errors. All right. So now if we type git status, notice that it doesn't tell us that there's this notes.txt file, but it does tell us that we have this unrecognized gitignore file. So clearly it's already reading the gitignore and knowing that it's supposed to ignore this notes file, but we haven't added the gitignore to the repository. Okay, so let's add it. Go ahead and add it, and then I'm going to commit adding a gitignore file. And now if we type git status, it looks like the repository is perfectly clean, and we don't see anything about those notes, and yet the notes are still here. So that's the basics of how you do how you ignore stuff in Git. You have to do this all the time. A lot of times I ignore my notebook files, my Python, my Jupyter notebook files, because Jupyter notebooks are often kind of scratch space where I'm trying stuff out and not really meant to be part of a repository. Just as an example, let me open that .gitignore file once again. And if, for example, I wanted to ignore all the Jupyter notebooks in this repository, no matter where they were or what they were called, I could just say star.ipynb on a line. So you can use stars just like you can in the terminal. If you're not familiar with this sort of like star.ipynb syntax, it's called glob. It's a way of specifying files where star can stand for any characters, basically. But the idea here is that this would ignore all the Python notebooks in my repository. Okay, and then I'm just going to go ahead
Question
and
on
commit
that.
Yeah.
So on the git commit, for the git ignore, I noticed that you didn't have to specify the git ignore. Is that because it's a special type of file? So like after you wrote the git message?
It's because I added it first. So if you git add a file or some number of files, then you can type git commit with a message and no files after it, and it'll commit whatever you've added.
Gotcha.
Yeah. Yeah. That's a great question. I think we should just test it out because I'm not confident in the answer to that. I think the answer is yes. So let's go to the moons directory. I'm just going to echo blah blah.
What was the question?
Oh, sorry. The question was, if we made notes.txt in other directories, would it ignore all of them, or would it only ignore the notes in the root directory? And I think the answer is it ignores all of them, but I said let's test it because I'm not certain. So echo is a command that will print a string to the screen, and if you just put a little greater than sign and then notes.txt, what it does is it will print blah blah blah, but it will print it into this file. So I'm just going to run that command and then cat notes.txt to test that worked. Okay, so that worked. So now if I type git status, there's nothing about that notes.txt in Moon, so it clearly did ignore it. Now, if you only wanted to ignore the root notes.txt, for example, and you wanted to have the notes.txt in the Moons directory still be part of the repository, to do that, we can edit the .gitignore again. And instead of saying notes.txt, we can say /notes.txt to mean the slash indicates the start of the root of the repository. So now if I push Control O to save and Control X and type git status, we see that there's this moons.txt file that we haven't committed because now it's only ignoring the root notes.txt. Yeah, good question though. I think there was another question. Did someone else have a question over here? No. Okay. Oh yeah, let me just cat it. Yeah, so what I did was I put a slash at the front of notes.txt. Yeah. Okay, so I'm now going to commit. I'm going to commit using a slightly different syntax, which is git commit -m. Notice I haven't added anything yet, so I'm going to git commit -m, adding git ignore, whoops, fixing. And then I'm going to put -a. -a stands for all changes. So what this means is git commit. I haven't added anything, so there's nothing to commit yet. Here's the message, but this -a means ignore what's in the stash, just commit all of the changes. So that will have committed the modified git ignore here. Now it's not going to have committed this notes because that's not part of the repository. It doesn't commit stuff that's part of the repository, it just commits changes it knows about when you say commit all changes. So if we say git status, we should still see that this notes.txt file is untracked. And I'm just going to delete that file so it doesn't show up continuously. Okay. Any questions so far? All right, we're actually making pretty good time. So the last thing we're going to talk about is we're just going to talk a little bit about how we sync with GitHub, the website. So keeping in mind that, as I mentioned, we pulled that empty planets repository down from GitHub, and that made a copy of that repository on our local computer. But when we commit to our local repository, it doesn't tell GitHub anything about that. So if I now go back to GitHub, and I'm just going to go to Noah Benson /planets. This is still an empty repository. There's nothing in here. It's still telling us how to set it up on our local computer. So GitHub doesn't know about any of the changes we've made yet. So, so if I go back to my terminal, the command to get this back onto GitHub is git push. What push does is it takes all the commits you've made and syncs them up to GitHub. So whatever is different between your repository and GitHub, it's going to try to make the GitHub repository the same as the local one here. That just worked. So here it's printed out a few things. This is a note about the I forget what it's called, the credentials. This is telling us some stuff about how many things have changed. But basically, all this is saying that this push was successful. So let's go back over to the planets repository, and I'm just going to reload it. And now there's things here. So now we have this moons directory, git ignore, mars.txt. And GitHub now knows all about this. And now let's suppose I cd space ... and I am just going to completely blow this directory away, delete the whole planets directory. So it no longer exists on my computer. There's no planets directory here. But if I now git clone it again, and go into planets, you'll see that we still have these files. So it just pulled, when I cloned it this second time, it went up to GitHub, and since we had pushed all of our changes to GitHub, it was able to pull all those changes back down to my laptop. And in fact, if we type git log, we'll see the same history of commits. So basically everything we did with the git command line, when we get pushed, it all went up to GitHub, all of that history and all of the changes we made. And when we clone it again, we get all those changes when we duplicate the repository. Does that make sense to everyone? Any questions about that? Yeah. Yes. Yes, that's right. So the question was is the notes.txt gone? And that's correct. When because it was ignored, it was never pushed into GitHub. And it was never pushed. It was never committed to our repository, and so it was never pushed to GitHub. And so when I deleted it, it was gone, and then when we cloned it, we didn't get that file back because it wasn't in the repository. Yeah. Yep. So that's an example of why you wouldn't want to necessarily do this all the time. But yeah, this is essentially how it works. So hopefully this makes it relatively easy to see how Git is useful for tracking your history of changes, of edits to files, and how it's at least partially useful for collaborating with other people. Now, we have just a few minutes left, so I think let's talk very quickly about pull requests. This is going to be a bit of a whirlwind because pull requests are a kind of big topic, but I want you to all be familiar with them so that you can at least look them up later. Basically, we've looked at repositories and how we can like add things to them and commit stuff and check things back out from earlier repositories, that kind of thing. But we haven't talked much about collaboration. And most of the time, when you're collaborating with someone else, you're going to be operating in one of two ways. One is that both of you own the repository and you can both commit directly to it. The other is that, for example, maybe I own the repository and you're helping work on it, and so you can clone my repository. But when you try to push to it, GitHub's going to say, wait a second, you don't own this repository. You're not allowed to push to Noah Benson / planets. You're only allowed to push to your own repositories. Will someone give me their GitHub username so I can do an example? Yeah. Like that? There, great. Okay. So here is Avery's planets repository. Remember, we made these repositories public, so all of you now have in your GitHub profiles this planets directory that anyone can go look at. And since it's public, what I'm going to do is I'm going to go over here. Whoops, not there. See up here in the upper right, there's this button that says fork. I'm going to push that button, and what forking does is it makes a copy of this repository that's mine instead. So basically, it takes Avery's repository, it makes a complete copy of it, but it puts it inside of my username. Since I already have a planets repository, I'm just going to call this planets1. I'm going to go ahead and create the fork. All right, so now this is Noah Benson / planets1. If I didn't already have the planets repository, we could have called this Noah Benson planets. That works a little better. But anyway, I've made this repository and it's mine. Okay. So now I can come back over here and I'm just going to blow away the planets directory again. And I'm going to clone git at github.com :Noah Benson /planets-1. Okay, so now I go into planets-1, and this is Avery's repository. It's just on my local computer now. So I'm going to open nano and edit mars.txt. I'm going to just add this line here, an additional change from another user, that user being me. I'm going to save this file, Control O, Control X, and I'm going to add and commit it. So git add mars.text, and I'm going to commit it external commit. Okay, so I was allowed to commit that because it was my repository. And that commit will have no bearing on Avery's repository because it only went into my repository. However, supposing I think that commit was important and I think Avery should know about it, what I can do is I can go up to this tab here that says pull requests. So, first of all, before I do any of this, I have to push that change. So I get push up to my my repository, and now we should be able to see, yeah, that additional line here. Okay, so remember we push things to Git if we want someone else to get the changes, we request that they pull from our repository. So that's why it's called a pull request. And what I can do is I can say I want to make a new pull request. And it creates this little box up here where there's an arrow here saying which direction are you pulling. And I basically want the information to go from my repository into Avery's repository. And it shows what the change is down here. It shows a little log of the commit messages. Okay, so I'm going to create a pull request. And I can write a little message here if I want that explains to Avery what I changed or whatever. And whenever I'm done, I can push create pull request. Now, there's now a pull request on Avery's repository, and you should get an email actually saying Noah Benson just made a pull request to your repository. And I cannot do anything here. I can make comments on this repository, but I cannot force Avery to pull my changes into her repository. Instead, Avery has to log in and go approve the pull request. And when she does, it'll merge my changes into her repository. Now, all of that may seem a little bit complicated, but this is how you interact with open source projects for the most part. If you are working on Nebabble and you realize there's a bug and you think you can fix it, you make a fork of Nebabble, you fix the code, you commit it to your username or your GitHub account, and then you send a pull request to Nebabble and they'll review it and decide it's good and they'll pull it into their repository. That's how pretty much anyone who works on open source code works for the most part, unless they're the maintainer of a particular repository. So this is a very common way that people interact with open source code. Yeah. That's a great question. Okay, I wish we had more time to talk about that actually. So for Zoomers, the question was, what happens if you make a pull request and the main repository that's pulling has changed so that your repositories don't sync up anymore? Yeah, so unfortunately, we didn't have much time to talk about that, but there's a whole workflow in Git called merging, where if there are multiple changes from different sources, what Git will do first of all is, oh, and thank you, Avery, for merging my pull request. You can see this just went to merged. Yeah, so Avery just merged my pull request. In the case of my pull request, there weren't any changes, so it was very easy to merge. You just made the insert. But if there had been changes, what Git would have done first was say, look at the changes and decide whether or not they were simple. If they were simple, if the changes were to different files or to different parts of the same file, it'll just treat it as a simple merge and just merge them for you. However, if we had made changes to the same file or the same part of the same file, then Git would basically say, hey, I don't know how to resolve this. You have to do it yourself. And it'll give you a file where it's marked the lines that need to be resolved and asks you, what do you want me to put here? You have two choices, the old version or the new version. And you basically go correct those yourself, and then that it'll merge according to your instructions. Yeah, so that's a great question. Yeah. Yeah. Yeah, so the question for Zoomers was, suppose that I made a whole bunch of commits and Avery opened them up and basically said, oh, I only want this one and this one, but not the rest of them. Yeah, so there's many ways to deal with that that are all in this pull request system. So there's ways to go and look at the files that have been changed. There's actually a lot of infrastructure here. You can request that people review your pull requests and all kinds of stuff. But ultimately, whoever owns the repository has total control over what gets merged. So they can selectively merge. It just may take a little bit more work. That's a little bit more advanced, so I don't think we don't really have time to talk about it today. And in fact, we're almost out of time. I just want to introduce one more concept before we finish because it's kind of important. And basically, so coming back here, I almost wish I had done this pull request in the other direction because it'd be easier to demo. But well, let me do it this way. I'm going to go back to my planets repository, and I just want to point out that you can. And actually, whoops, let me go back here and git clone. So this is, I'm going to git clone my planets repository once again. So I have a copy of it here and cd into it. If I go over to GitHub, something that I didn't mention, but that's kind of nice about the GitHub website is that you can actually edit these files here by clicking that little pen icon. And it will make a commit and everything for you on the website. So here I'm going to add one more line. And I can scroll down here and I can say, here's my commit message. I added one more line. And I can commit those changes, and that becomes a new commit in the repository that exists on GitHub. Okay, so now I have made a change to my GitHub repository since I cloned this repository. So over here, if I cat mars.txt, it doesn't have that line yet. So one thing I could do is I could just delete this whole repository again, and I could reclone it, and I could get that new line. But that's cumbersome. So instead, what we typically do is Git Pull. And Git Pull just goes to GitHub and asks it for anything new. And there it's basically said, yeah, here, there's a change to mars.txt that it's now updated. So if I cat mars.txt now, we'll see that one more line. And we can also see the commit message. Whoops, added one more line in the Git log. So that's how you pull things from Git. Yeah. Mm-hmm. Yeah, great question. So, oh, on Jupyter. Oh, sorry. Okay. So the question was, is there a limit on storage and space? I actually don't know what the limit is on Jupyter. It's pretty big. I wouldn't go cloning terabytes into your Jupyter hub directory, but they're intentionally made to be pretty expansive so that later in the hack week you can all work on big files and stuff. So and if you have trouble with that, come talk to us because we have ways of giving you more space and things. Yeah. Yeah. So the question was, is there an advantage to using the terminal and SSH key versus the GitHub desktop UI or something like the website, I presume? Honestly, the main advantage of using the terminal is that you have a terminal you can use. So for people like me, like I do a lot of coding in the terminal. I do a lot of like loops in Bash where I will go and like edit individual files with just a single Bash command. If you don't do a lot of that stuff, if you're fine editing things on the website, there's really no disadvantage to editing on the website. I just happen to like my terminal tools, and when you have bigger repositories and you have a lot of files and you may need to, do things to many files in a single command or something, it's just much easier to do it in the terminal. So that's the main reason. The other thing is that I didn't really talk about, but GitHub is just one way of doing Git. GitHub, the website, is a Git server. There are other Git servers out there. This is just one of them. And in fact, you can run your own Git server and have it all be private, for example, and that's totally doable. A lot of people avoid GitHub just because it's now owned by Microsoft, and they're afraid Microsoft is going to start charging for it or something. I don't really have much insight into that, but the basic point is just that Git is its own command. It's a tool for this kind of collaborative code editing in particular. GitHub is just a server for it, and so it's one way to interact and store your code, but it's not the only way. Yeah. Yeah, so I know very little about GitLab, to be honest. I believe it is a Git server with some extra tools added on. But sorry, unfortunately, I've never used GitLab myself. I do know it's a kind of popular tool. It is very related to Git, but I don't know precisely the differences. Yeah. Ah. Oh. Okay. So for people on Zoom, I'll just paraphrase. Basically, the question was, GitLab is another tool. What's the difference between GitLab and GitHub? My response was, I don't really know. I don't use GitLab, but Adina just answered saying, GitLab is an open source version of GitHub, basically, where you can run it yourself, and it has small differences, like instead of a pull request, you do a merge request, but and it doesn't have quite as many of the bells and whistles that GitHub does, but otherwise it's pretty much a version of GitHub you can run yourself. Any other questions? I think we're a little over time. The coffee break's already started, but I'm happy to stick around and answer questions as long as people have them. So otherwise, thanks for joining, and I'll see you back here in half an hour for the Docker lesson.
Can I ask a question?
Yeah, sorry, multiple questions at once. I'll start with Zoom. Hello, person on Zoom.
Hi.
Yeah, what was your question?
Yeah, it's a very general question. I'm sorry if I have missed this at the beginning. I wonder if everything will be the same if I want to pull and push from a computing cluster rather than my personal computer to GitHub?
Yeah, that's a great question. It actually pretty much is the same. You have to do the configuration of the SSH key and stuff on the cluster, but once you've done that, all the commands will be the same.
I see. Awesome. Thank you.
Yeah, and what was your question? Well, I'll tell you about the history command. There's a command called history, which will tell you all the commands you've typed recently. There are really sophisticated ways to save everything in a terminal out, but they're not easy. They would take a lot of engineering to get to work. Unfortunately, I don't have a way to do that offhand. You just have to copy and paste. Sorry. Any other questions? Yeah. Yeah, exactly. Yeah, so you can't, yeah. Remember earlier I said echo, whoops, well here. I said something like echo blah, blah to, oops. And you notice this little greater than character. That greater than character means whatever the output of whatever command is on the left of it, put it in the file on the right of it. So you can type history and that'll show you your history, or you can type history arrow history.txt, and then history.txt will contain your history. Okay, any other questions? Yeah. Yeah, so Git and GitHub are related in that Git is a tool for interacting with a repository locally and also syncing to other repository stores. GitHub is a repository store. It's a place where you can store repositories in the cloud, and you can sync to and from it and that kind of thing. But yeah, GitHub is essentially it's a Git server or a Git storage server. Yeah. Yeah, right. So if you're running GitLab and you push to GitLab, it's the same idea. Yeah. Yep. All right. Thanks everyone for coming. I'll stick around here. I'm got to set up for the next lesson anyway. So if you have more questions, you can come down and ask me. I'm happy to answer. But otherwise, yeah, coffee breaks outside.